Alright, good morning. I am sorry that I cannot be with you today, but this is a good opportunity to practice this specific type of instruction. Hopefully this video lesson is helpful. It will allow you to work at your own pace. If you've never done something like this before, I do believe that we have some experience. Those who had me as a teacher in 6th grade, we did this a little bit. So the great thing about this is at any point during the video lesson, if you missed something, need to slow down, need to go back and pick up something you missed, you can always pause the video and rewind, or just pause it and kind of catch your thoughts, collect your thoughts rather. So please feel free to do that along the way. From as far as structure is concerned, brain breaks and Kagan strategies, we're going to kind of put those on the back burner for today, and this is going to be a relatively independent time for you today until at least you get to the end. So for today, here's what I would like you to do. I would like you to spend your first 5 doing this quick check and pause the video, work out the problems, come back to the video when you are ready to check answers. And we're back. Here are the answers to those questions. 0.875 if you divide 7 by 8, 0.416 with bar notation over the 6, indicating that 6 is the digit that will repeat. And for number 3, you have 2.15. Number 4, for decimal of fraction, 2/25, or 2 over 25 for number 4, and 1 3/8 for number 5. I would be happy to discuss any of these with you when I get back if you are not sure. Hopefully you nailed those though. For number 6, 11.8 inches as a mixed number is 11 4/5. That is choice C. Hopefully you're good there. Moving on, essential question again. Why is it helpful to write numbers in different ways? Hopefully you've seen so far, depending on, a lot of times, sometimes fractions are easier to work with, sometimes decimals are preferred within the context. We had the one example that was batting average. Batting average obviously is given as a decimal. You have dollars and cents. You have a variety of things that can help you in terms of how to write numbers different ways. Our I can statement for today is I can write and evaluate expressions, expressions, expressions using exponents. I don't know if you've looked ahead to this yet. Take a sneak peek. Exponents. So I can write and evaluate expressions using exponents. Again, please feel free to pause the video at any point if you need to catch up. Moving on to the next page. Vocabulary. Alright, so our new vocabulary is associated with 3 words that you're going to see a lot of. You're going to see a power, you're going to see base, and you're going to say exponent. So I'm actually going to start with base, and our example always goes on the left, and our definition always goes on the right for right now. So I'm actually going to write the exponential notation, 3 to the 2nd power. I'm going to do the same thing here, 3 to the 2nd power, and I'm going to do the same thing here, 3 to the 2nd power. So here's the deal with this. Base starts with the letter B. The word big also starts with the letter B. So if you can remember that, the base is the big number. In other words, the 3 in this case. The exponent then is the smaller number. So if I can quickly change colors here, or potentially use a highlighter maybe. No, we'll just change color for right now. So the base right now is the 3. The exponent is the 2. The power is the whole thing. It has to have both. Okay? So simply put, the base is the number being multiplied. It's a number being multiplied. A number. Obviously it's in exponential notation. This is really crummy, guys. I'm sorry. Let me erase this and start over. Okay, 'cause I might want to even type it. Make it easier for you to see. And there's some growing pains here. They actually updated this particular program that I'm using to type. So where was I? Base. Okay, so I'm going to move it down in a second. Base is a number being multiplied. Sorry about that. I don't know why it's not moving for me. Alright, so, oops. I understand why I can't move this thing. Well, we can make it smaller. Now I can move it. Great. That's what I want. A number being multiplied by an exponent. Sorry for the delay there. The exponent itself is a number that tells how many times the base is multiplied by itself. Here, multiplied by. I'm going to change this definition a little bit, just make it a little bit more user-friendly. Okay, certain number of times. So it's being multiplied by itself. In other words, 3 is being multiplied by itself twice, 3 times 3 in this case. The exponent tells you, sorry about the delay again, a number that tells how many times the base is multiplied by itself. Awesome. Okay, so the power then is a value that consists of a base and an exponent. If you don't have both, then you don't have a power. Powerless without the base and the exponent. It has to have both. So power is both a base and an exponent. The base is the bigger number being multiplied by itself. The exponent is the smaller number, and it tells how many times to multiply the base by itself. Okay? Pause that if you need to, otherwise we're going on. Examples. Write the expression using exponents. Okay, so this is going to look a little bit like factorization, prime factorization, which we had an example of, and I specifically told you not to use exponents. Now we are going to. So really simply put, you're going to have, in this case, there's two different numbers. You're going to have two different bases. And so why parentheses? Well, parentheses help separate the negative sign from it looking like it is subtraction. So this is just simply a detail that math people appreciate. When you're multiplying by negative numbers, we like to put the factors in parentheses. So if I'm going to represent this number, it's going to be negative 2 inside parentheses. And how many negative 2's are there? 1, 2, 3. So negative 2 is being multiplied by itself, which means I'm going to go ahead and have an exponent of 3. Whoops. I'm going to throw that right up there. I can make it a little bit bigger. There we go. Negative 2 to the third power. So there's 3 of those. And then it's times. To be honest with you, you don't really need the dots there, in my opinion. Suppose put 1 anyways. Times. That's awesome. And then how many 3's are there? 1, 2, 3, 4. So times 3 to the 4th power. So 3 to the power of 4. And shrink that down a little bit. Throw that up top, and we're done. So negative 2 to the 3rd times 3 to the 4th. That would be the expression in exponents. It's not asking for an answer. Please don't give one. You don't have to simplify it just yet. This is your final answer right here, because you're using exponents to write that expression. Okay? Take a couple of minutes. Please pause the video. Do this one by yourself. When you are ready to check your answer, unpause it and continue. Alright, so you should have negative 9 to the 5th times 4 to the 3rd. There are 1, 2, 3, 4, 5 negative 9s, 1, 2, 3, 4s, and that is what that expression looks like using exponents. Okay, again, not giving an answer yet. Number 2, you can do the same thing with variables. So these are numerical expressions because numbers are involved. What we're going to look at next are variable expressions because there are letters involved. Hopefully you know what a variable is by now. It's a letter that stands for an unknown value. I'm going to apply the same strategy to the letters as I did to the numbers here. So we're simply going to count each letter. I see 1A and 2A's, and I see 1, 2, 3 B's. So it's not 2A, 3B because that's not how it works here. 2A would be like A plus A. A plus A equals 2A. B plus B plus B equals 3B. That's not what's happening here. These numbers are being multiplied. So just like I did up here, anytime I'm multiplying a number by itself, I'm using an exponent. So A times A becomes A squared, and B times B times B is going to be B to the 3rd. So we got A squared. And so here's the thing. Up here, I was mentioning this dot earlier. It is necessary for numbers. It is not necessary for letters. So you can simply write this as A squared B to the 3rd power, just like this. We don't need the dots in between the A's and the B's. This is pretty standard in terms of how math people appreciate having variable expressions written. And of course, because there are no numerical values yet, I can't do any solving anyway. So this is the expression using exponents, A squared B to the 3rd, and we're done with that. So again, you go ahead and try the next one here on your own, x times y times x times y times x times x, as an expression using exponents. Do that one on your own, pause the video, and then come back when you are ready to check. Okay, so we have 4 x's being multiplied by each other, 2 y's being multiplied by each other. That becomes x to the 4th y squared. Typically in math, this is another detail. Math people appreciate having variables written in alphabetical order. Okay, so if you had y squared x to the 4th, it's not that it's wrong, it's just not completely right. It would be similar to not simplifying a fraction to lowest terms. Like you would still technically have the same correct value, but not written correctly, not simplified properly. So in terms of points, yeah, you would probably lose a point if you had y squared x to the 4th, because I'm telling you now, here's your warning, write them in alphabetical order. Okay. By the way, again, I'll keep saying it. If at any time during this you need to go back and review something, or if you miss something, please pause, rewind, etc., because we're going to move on. Now we're going to evaluate according to the Kahoot we took last week. Evaluate means calculate, essentially. So we're going to come up with a simplified response to these expressions now. Alright, we need to consider a couple of things. We need to consider positives and negatives. We need to consider what exponents mean. In other words, in this particular case, I wish it would have started us off with a whole number. It doesn't. Oh well, we'll figure it out anyways. So, negative 2/3 to the 4th power. Here's how I recommend you do a problem more like this. Now, for some of us who have strong math ability, this may seem a little elementary to you. I don't care if it seems elementary. I consider myself somewhat of a math expert, and I still do my math like this. So hopefully you're not too proud to do it like this. So here's what I would do. Each of these is going to get parentheses, right? Negative 2/3 times negative 2/3 times negative 2/3. Remember that I'm putting the parentheses around these so it doesn't look like subtraction. It looks like I'm multiplying negatives. Alright, negative 2/3. And do I have 4 of them? Yes, I do. So, I need to remember a couple of things. First of all, the rules for multiplying and dividing integers says if I am multiplying or dividing and I have an even number of negative signs like I do here, 1, 2, 3, 4, my end result is going to be positive. So I know that my answer to this is going to be positive. I also have a pretty good idea that it's going to be a fraction based on the fact that it started out as a fraction, and it's most likely going to end up like 1, at least until I simplify it. So After that, all I really need to do then is apply the rules of multiplying, which says when I'm multiplying fractions, I simply multiply across the top and I multiply across the bottom. Simplify as needed. And I believe what you're going to find is the issue here is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16. So I'm going to have 16 on top. 3 times 3 is 9, times 3 is 27, times 3 is 81, and I'm going to have 81 on the bottom. I personally know that there is nothing to divide here because there was nothing to cancel along the way. 2 and 3 don't go into each other, right? So 16 over 81 is the simplified version of this fraction, and I'm going to leave it just like that, positive 16 over 81. You try the next one, pause the video and come back when you're ready to check. So this one is pretty cut and dry. 1/4 to the third means 1/4 times 1/4 times 1/4. So again, this exponent is telling me how many 1/4s I'm multiplying by itself. In this case, I have 3 of them. So no negative signs to deal with. I know my answer is going to be positive, and I just need to multiply across the top. 1 times 1 times 1 is 1. 4 times 4 is 16, times 4 is 64 on the bottom, and that's it, 1 over 64. So again, if you have any questions about that or you missed something, go ahead and rewind before we move forward. Otherwise, we are going to move forward. Now we're going to apply our exponent rules for expressions to word problems. So here we go. The deck of a skateboard has an area of about 2 to the 5th times 7 square inches. What is the area of the skateboard deck? So, a couple of things to keep in mind. First of all, it's a word problem. Word problems generally have labels, so I'm going to need a label here. I found it already. It's right there. Square inches. That's going to be the label. How do I know, or how can I verify? Because it's asking me for area. Area is always square units. There are my units, square inches. It's asking for area, so I know that my answer is going to be in inches squared, or square inches. You might want to write that down just to remind yourself. And then all I'm simply going to do is calculate this numerical value then. So 2 to the 5th, what does that mean? It means 2 times 2 times 2 times 2 times 2. So again, the exponent 5 is telling me 1, 2, 3, 4, 5 2's are being multiplied together. 2 times 2, and then I have the 7 also. So you can actually do this in any particular order. Remember, commutative property says that the order of multiplication is not important. So it may actually not be a bad idea to go 7 times 2 and continue to double that value as you go back. So 7 times 2 is 14, times 2 is 28, times 2 is 56, times 2 is 112, times 2 is 224 square inches, or inches squared. That is the area of the skateboard deck, 224 inches squared. Okay? Take a minute and do the second part of number 4. Pause the video while you do that, and when you're ready to check, come back and revisit. So again, we're talking about area. How did I know that? Because it says area right here. Square feet is my I should say are my units. Okay, so my finished response should have square feet in the answer for the label. 2 times 4 squared, so 4 squared is 4 times 4. 5 squared is 5 times 5, so I'm doing 2 times 4 times 4 times 5 times 5. Again, order is not important. What I personally did was, found compatible numbers. 5 times 5 is 25. 25 times 4 is 100. That's pretty easy to work with. So then times 4 is 400, times 2 is 800. That gets me to 800 square feet. There is no wrong way to multiply these in terms of order, as long as you get the same answer. Okay, so just remember that order is not important because of the commutative property. My answer to this one is 800 square feet. All right. Again, rewind or review if you need to. Otherwise, we're moving on. We only have a little bit more to go here. Number 5. Now we're going to evaluate expressions by substitution. Okay, so it's going to start as a variable expression right here, a squared plus b to the 4th. And it says evaluate, so in other words calculate if the expression, evaluate this expression if a equals 3 and b equals 5. So all I'm going to do is simply substitute 3 in for a, move this guy out of the way, and 5 in for b. Okay, and I'll show you what that looks like. Let me erase. it's going to look very similar to the previous examples before I start anyways. So I'm going to simply rewrite this expression using the numbers. Be very, very careful that you don't flip them around. In other words, don't put 5 there and 3 there. So if a equals 3, that means this is now becoming 3 squared. 3 gets substituted in for a. And 5 is going to be substituted in for b. So there you have it. If it said write the expression, then we'd be done. But we want to evaluate it. So we need a final answer that is numerical. Don't forget order of operations here. To be honest with you, it doesn't really matter which exponent you do first. 3 squared means 3 times 3. That's going to be 9. 5 to the 4th is going to be 5 times 5. Whoops, sorry. Oh no. Edit, undo. Reset page. I don't want to do that. I guess I'll just paste it. Oh, that get all messed up. No big deal. Where were we? Okay, here. So, sorry about that. Growing pains. At any rate, 3 squared plus 5 to the 4th. Okay, so this means 5 times 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. So back to this part, I have 9 plus 625. And I'm going to go ahead and add that together and get 634. All right, done. Right there, there's my answer. Finished. So again, you're going to try the second one, x to the 3rd plus y to the 5th, if x equals 4 and y equals 2. Again, pause and knock this out individually, come back and check when you're ready. Alright, so I've kind of gotten started here. Substituting 4 in for x gives me 4 to the 3rd. Substituting 2 in for y gives me 2 to the 5th. 4 to the 3rd means 4 times 4 times 4. 2 to the 5th means 2 times 2 times 2 times 2 times 2. Mr. Anson, do I have to show my work? Yes. How much work you have to show, though, is kind of based on your own individual mental math skills. I want you to use mental math in certain instances, but I also want you to show your work where necessary. So here it is necessary, especially when you're not using a calculator. All right, because I want to be able to give you partial credit. I can't do that if you just have a wrong answer. I have to mark the whole thing wrong. So we're going to continue from here. 4 times 4 is 16, times 4 is 64. We had something like that earlier. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I'm going to go ahead and add those together, and I'm going to get 96. If you need to see that repeated again, go ahead and rewind and play it back. Last but not least, evaluate the expression. Okay, so what you'll notice here is that there are parentheses around the subtraction part, which means if you remember order of operations, parentheses come before exponents. Why am I doing it this way rather than writing it as a word? Because I work from the top down. It's easier to remember, just like that. So when I'm doing parentheses, they obviously come before exponents. Multiplying and divide, which we'll get to later. Whoops, sorry about that. Multiply and divide goes in order from left to right. In other words, whichever one I come to first in the problem, I will do first. Same thing with addition and subtraction. It does not mean always add before you subtract. That's not what it means. It does not mean always multiply before you divide. It means whichever comes first from left to right. So, same basic premise. I'm going to be substituting first. So I'm going to take the 3 and put it in for A. I'm going to take the 5 and put it in for B. That looks like this. I would strongly recommend that you keep the parentheses here, because that's all I did was change the A for the 3 and the 5 for the B. Everything else stays the same. Parentheses stay the same, subtraction stays the same, exponent stays the same. So, next thing to do is calculate what is inside parentheses. 3 minus 5 is negative 2, not a trick question. I would also leave my response inside parentheses. I'll show you why in a second. So I have negative 2 squared, which technically means -2 times -2. My rules say that an odd number of negative signs is negative, and even number of negative signs is positive. So 1, 2, that's going to be positive. So this final answer is going to be 2 times 2, which is positive 4. Why does it matter if the exponents are there? Because let's say I had this without it. Well, I'm sorry, parentheses, without the parentheses. Technically, whenever there is a negative sign, it means -1 times whatever this situation is. So that means this is -1 times 2 squared. So if I think about this in terms of order of operations, exponents is right here, multiplication is right there. So I'm going to do the 2 squared first and then multiply by -1. Well, that's a totally different story now, isn't it? There is a big difference between 4 and -4, is there not? Would you rather owe somebody $4 or have somebody owe you $4? Kind of a big difference, right? So this is not correct. It's not what we're doing here. We're doing it this way. Keep it inside parentheses, because then you have to do the negative rules, which is even number makes it positive. Okay? I know it was a little tricky, so if you need to replay that one, be my guest. Otherwise, go ahead and try this last problem on your own. Come back when you are ready to check. Alright, so again, substituting 4 in for x, substituting 2 in for y, gives me parentheses 4 plus 2 squared. I do what is inside the parentheses first. I add 4 plus 2 and I get 6. And then I square that, so that means 6 times 6, which gives me 36. Hopefully you didn't have any trouble with that. If you did, feel free to rewind, check it out. Sample answers to our question, again, talking about using powers. Using powers allows us kind of a shortcut way of writing bigger numbers that would be getting exponentially bigger because we're multiplying the same thing by itself. And then you also use exponents when you're using the metric system, believe it or not. So metric is base 10. So when you're talking about millimeter, centimeter, meter, kilometer, those are all base 10 system. Okay, centi means 100, so milli means 1,000, kilo means, you get the idea. So it's helpful in the metric system. Okay, so we are going to use a Kagan strategy or structure. You're going to Rally Coach, page 18, 1 through 9, which is the guided practice for this lesson. Now, the caveat, of course, is, if you're at a different place in the video than your partner, you're going to have to wait for that person to be done. But you're going to do this with your shoulder partner. Ideally, we're all finishing within about the same time. If you want to work by yourself, I don't have a problem with that. But I would encourage a collaborative learning environment. Make sure that your conversations are structured. Make sure that they are focused on page 18. Be encouraging of each other. Okay? Compliment each other. Don't make fun. Don't pick on each other. Try to avoid sarcasm. I want this to be a caring environment in which people are going to be successful. So, Rally Coach that. Page 18, 1 through 9. When you're done with that, independent practice, if we have time to start on your homework, you may do that. It's page 19. And the IXL skill that goes along with this lesson is in the 8th grade tab, V as in Victor 4, V4. All right. I hope to see you sometime later today. I should be back by about 11:30 or so. Enjoy your day. I hope you found this helpful, and have an awesome day.